Here we're being asked to graph y less than or equal to 2x minus 1. Now for this problem, I don't need to tell you that we're graphing it in the plane. There's no way I could graph it on a number line when I have two variables. So if there are two variables and you're asked to graph something, you know it's in the plane. If your inequality involves just one variable, I would have to tell you, I want you to graph it in the plane, or I want you to graph it on a line. Okay, but it's going to basically be our same three-step process. I'm going to figure out what the boundary is. So the boundary is always what I get by replacing the inequality with an equal sign. Because where two things are equal is the boundary, where on one side of that boundary one thing is bigger, and on the other side of the boundary the other thing is bigger. Okay. So the boundary would be y equals 2x minus 1. Now you'll notice that's a line. So in this case we're getting a boundary line, and it's a diagonal line instead of a vertical line like the last example. Okay. Now before I graph that, I need to know whether the boundary is included or not. Because this is less than or equal to, the boundary is included. If it's a strict inequality, it would have to be not included, and then I would use a dotted line. If it's an inclusive inequality, the boundary is included, and so I'm going to graph that as a solid line. So I'm not numbering my steps here, but I'm following this same procedure. Figure out what the boundary is by replacing the inequality with an equal sign. Determine whether the boundary is included or not. And I like to actually write down. If it's included, I write down solid line. And if it's not included, I write down dotted line. That's because I'm so used to when I'm graphing just connecting the dots with a solid line or a solid curve that I find it helpful to have it written down if I'm not supposed to do that. In this case, we're good to go because this is a solid line. So 2x minus 1. So I know that the y-intercept is down here at 0, negative 1. My slope is 2. Remember, the number in front of the x is the slope. I can view that as a fraction, 2 over 1. So that tells me I'm going to count up 2 over 1. That gives me a second point on the line. And then since it's a line, I just connect those points. And of course, I'm connecting them this time with a solid line. Okay. So you'll notice this line divides the plane up into two parts. There's this part here, which is sort of above and to the left of the line. And then there's this part here, which is below and to the right of the line. One side of that line is going to make this inequality true. That's going to be where the y values are smaller than the y values on the line. The other side is going to make the inequality false. That would be where the y values are bigger than the y values on the line. So I need to figure out which side makes the inequality true and then shade that side. Okay. Now I have two options for figuring that out. In this case, because I have y by itself, I'm looking for where my y values, I know where they're equal to 2x minus 1. That's on the line. So I want to know on which side are they smaller than that. But I know what it means for y values to be small. That happens lower down. So that tells me I want to shade below the line. So that would be my answer, like so. Okay. So for shading, there are basically two options for figuring out how the shading works. So shading, option 1. If y is less than something, or y is less than or equal to something. So if I have a y by itself, now I might not always have that, okay? But if I have y by itself, that means I'm going to shade below. Because that's where my y values are smaller. If I have y is bigger than something, or y is bigger than or equal to something, okay, where this something here should just involve x's and numbers. It shouldn't have any y's in it. So I have y by itself, and the only y is by itself on the left. Here we're saying, where are my y values bigger? Y values are bigger higher up, so I would shade above. Okay. That's generally the technique I find simplest if my inequality has a y by itself, or I can easily get y by itself. But there's a second option, and some of you might prefer it even for a case like this. And option 2 is going to be necessary in some cases, because when we get to nonlinear inequalities, I guess I don't have the word nonlinear on the board. When we get to nonlinear inequalities, we won't always be able to get y by itself. So option 2 is to pick a test point. The important thing about the test point is that it has to clearly be on one side of the line or the other. So I wouldn't want to pick a point like right around here, where if I'm just off by a little bit, it could be on the other side of the line. Usually I will go with the origin if I can. If it's obvious which side of the boundary the origin is on, that's my easiest point. So I'm going to pick 0, 0. Notice that's on this side. Okay. And then I'm basically going to ask myself a true-false question. If I plug in 0 for x and 0 for y, does it make the inequality true, in which case I would want to shade that side? Or does it make the inequality false, in which case I would not be shading that side, so I'd be shading the other side? Okay. So if I just copy 0 less than or equal to 2 times 0 minus 1. And I might want to put a little question mark here to see if that works. Or alternatively, I could just work with y and 2x minus 1, okay, and create a table like so. 0, 2 times 0 minus 1. This would become minus 1. So now the left-hand side is 0, the right-hand side is negative 1. Is it true that 0 is less than or equal to negative 1? No. Negative 1 is smaller. Negative numbers are smaller than 0. So that would be false. So if I put my finger here at the origin, which was my test point, that's on the side of the line that I don't want to shade. So then I can say, oh, so I must want to shade the other side, and that's what I would do. Okay. So again, 2 options for figuring out the shading. If you've got y by itself, and you could do something similar if you had x by itself, I know where y is smaller and where y is bigger, so I can just think in terms of am I shading above or below the boundary curve. Other option, choose a test point, usually the origin if it's obvious which side of the boundary the origin is on. Do a true or false test. Does it make the inequality true or false? If it makes it true, shade the side that includes that point. If it makes it false, shade the other side.